Hey guys, it's Spiral Review for Spiral 25. We're going to look at a couple different ways to do some of these problems, so this might take longer on some pages than we're used to, but otherwise, we're almost there. So first problem here, we get a population of lemurs living in the woods north of here. We need to figure out something about the growth rate to see if population is healthy, and you're a lemurologist. It falls on you to figure this out. Okay, so last year there were 851 lemurs living in the forest. To me, that gives me a point that might be 2016, 851. In 2011, there were 735 lemurs living in the forest. Okay, so to me that might mean that we have another point, 2011, 735. And we're also told the population grows exponentially. Okay, so we're looking at some kind of amount is equal to the initial amount, 1 plus some kind of a growth rate to some time frame. Write an equation to represent the population of lemurs T years after 2011. That's kind of a big deal. After 2011 means I could reset this to be 0, 735, and this instead of 2016 would be 5 and 851, which are much nicer numbers for me to deal with. To figure out what this growth rate is, I first might need to think about what we have here. We have a starting population. Starting population you might recognize as that p-value for our principal amount. However, you could also set this up in terms of y equals ab to the x, and you'd end up with the same result that we're going to end up using this format. So, long story short is that this initial amount is going to be my p-value. Okay, and after 5 years, that's my t-value. We have 851, that's my final amount. We get an equation that's going to start off by looking at this. So 851 is equal to 735 times, we don't really know what this one is yet. I'm going to just call it 1+% right now, or some kind of a growth rate, to the 5th power. I'm going to divide by 735, and if you'll bear with me, type things into Desmos again. So we got 851 divided by 735, and that's equal to 1.157823, and that's equal to 1 plus some percent to the 5th power. To get rid of that 5th power, I'm going to take the 5th root of both sides. And in doing that, so 1.157823, the 5th root, or the 0.2 power, we have 1 plus our percent rate is equal to 1.0297. Okay, so that's looking at 2.97%. Going a little bit further, our model would be the amount in a given year is going to be the initial amount, 735, times 1.0297 to the t, where t is years after 2011. And that's what I'm going to use to figure out this year. And this year, when I'm writing this, happens to be 2017. Okay? So you've got A is equal to 735, 1.0297, and t years after 2011, 2017, that's going to be 6. So we're looking at 735 times 1.0297 to the 6th power, which is 876.09. So I'm going to say that's close enough to 876 to call that 876 lemurs. Next part of the question says that a healthy population of lemurs in woods like these grows approximately 5% each year. This population had a growth rate, and we figured that up here, of 2.97%. 2.97% is less than 5%. So to me, they are not healthy. Another lemurologist comes and offers you two possible solutions. The first is restricting the use of pesticides, and that would increase the current population growth by 3%. So just, I'm going to call this pesticides. And my growth rate would be 3% plus 2.97, 5.97%. So my equation for that would be A is equal to 735. 1 plus 0.0597 to the t. And then the second option is that we restrict the existing hunting season on carnivorous reindeer. In other words, there would be more of these natural, totally real, not fictional predators of the Massachusetts lemur, also totally fictional, not totally real, not fictional, which would then decrease the population by 4%. So right now they're at 2.97%. I'm going to call this the predator method. And 2.97 minus 4% is going to be negative 1.03% per year. So write models for each situation. So we're looking at, for this guy, A is equal to 735. That's a 3 and then a 5. 1 minus 1.03% to the t, which is going to be 1 minus 0.0103 to the t. All right. What we're trying to do is figure out what's going on in 2027. So 10 years from now, or 16 years after this whole experiment began. All I'm doing for that is plugging in numbers. So for my first one, we've got 735 times 1.0597, and that's to the 16. And based on this model, there would be 1858.72, or about 1858 in terms of lemurs. You don't have partial lemurs in a real-world scenario, although if this is an estimate, we can say it's a half of a lemur. It's not like we're actually cutting in half or something. It's only a mathematical model. For the other one, we're doing the same thing, but instead of the positive growth, we're going to have 1 minus 0.0103. In this case, we'd have 622.79. Somewhere around 622 or 623 lemurs would be present in that particular strategy. Next up, we've got some right triangle trigonometry. For the first part, we're looking at a given value and then trying to base some other trig research on that. I only tell you that we're looking from 0 to 90 because, well, it also should be a phi. I want to keep this in a right triangle. By the way, the new Greek letter we're looking at today is going to be phi or phi, depending on who you talk to. And it's just another Greek letter that we use occasionally as a variable. I figure, why not give you the chance to learn more and more about Greek variables in mathematics? So first thing first, I might want to make a triangle. I'm going to call this guy phi. And if this is tangent, that could be root 5 and 2 root 11. Pythagorizing, we've got 5, which is the square root of 5 squared, plus 4 times 11, which is this guy squared, is equal to c squared. In that case, c is going to be 7. Wow, I gave you something that comes out with a nice number? How cool am I? I know, I'm really cool. Sine is going to be opposite over hypotenuse, or the square root of 5 divided by 7. Cotangent is going to be adjacent divided by opposite, or 2 root 11 over the square root of 5. BT dubs. We had tangent before. I asked you for cotangent. All we did was the reciprocal. Ooh, that's sneaky. Cosine of 90 minus theta. Well, if this 90 minus phi, if this guy's phi, and this whole triangle is 180, that means we're really talking about this top complement angle. So cosine of this top angle would be adjacent over hypotenuse, or the square root of 5 over 7. Hey, cosine of the complement of phi is the same as sine of phi. Those two are related. Cool. Tangent for the same angle would be opposite divided by adjacent. 2 square roots of 11 divided by the square root of 5. And hey, cotangent and tangent are also related. I wonder if cotangent comes from the complement. Oh, in the same way that cosine does. So cotangent could be the tangent of the complement by definition. I think that's pretty fantastic. So I'm going to send you to be stationed at a radar base where you observe an unidentified plane at an altitude of 5,000 meters, okay? Altitude is up, so that's 5,000 meters, and an angle of elevation of 30 degrees. 30 degrees. After exactly 1 minute, okay. Now we're at 60 degrees, maintaining the same altitude, so that's still 5,000. I'm going to be super sneaky, and I'm going to say that this bottom one is going to have an x distance of 2,500 because I recognize this is a special right triangle. For the other one, I'm going to pretend I don't, and I'm going to find this by saying tangent of 30 is equal to 5,000 over x. That means I'm going to multiply by x and divide by tangent of 30. So x is equal to 5,000 over the tangent of 30. And if I do 5,000 divided by the tangent of 30, I get 8660.25. Nice. So now I figure out how far this plane has come, which, by the way, if it was 8660 and now it's 2,500, 8660 minus 2,500, it has come 6160 meters. Oh, man, but I've got to figure out the speed. So I've got to figure out the speed in meters per second. So if it came 6160 meters in 1 minute, okay, so that's like 60 seconds. If I divide those two, I should get my answer. So 6160 divided by 60 seconds is 102.667 meters per second. Nice. We just use trig to find something else out besides just a length. I think that's pretty awesome. Next up, we're going to a theater. We've got Katie on the floor level. I'm going to say Katie is A to see the, she looks down at an angle of 18 degrees to see the orchestra pit. Okay, so pit's down here. Let's call that P. And that's going to be 18 degrees. Kim, I'm going to call Kim M for Kim, is directly above Katie, so this distance is the same. But Kim looks down at an angle of 42 degrees. The horizontal distance is 46 feet. So that's 46 and 46, and that's because they're directly over each other. So I want to know what the distance between these two is going to be. And to do that, I'm going to find the height of both triangles. I'm going to call the big height Kim and the small height Cat, because I don't feel like writing the whole name. Okay, so I might write this as tangent of 42 degrees is equal to Kim over 46. And when I do that out, so 46 times the tangent of 42, we get Kim equals 41.418 feet. Okay, now Cat. Tangent of 18 is equal to Cat over 46. So if I were to do this out, we end up getting 46 times the tangent of 18. We find out that Cat is 14.946 feet above the orchestra pit. If we want to find the vertical distance between these two, we've got to subtract them. So 41.418 minus 14.946. 41.418 minus 14.946, and we get 26.472 feet. If you wanted to round this to the nearest inch, you'd say this is 26 feet, and 0.472 times 12, because they're 12 inches in a foot, would be plus 5.664 inches, or 26 feet 6 inches. Next, we've got Susan and Jorge. They're visiting London and just left the Houses of Parliament. Currently, they stand 38 meters apart, both to the west of Elizabeth Tower, the tower holding Big Ben. Thing number one you just learned, Big Ben is not the name of the tower. It's actually the nickname of the bell, which its real name is the Great Bell, but Big Ben's more fun, of the bell in the House of Parliament. And the tower in 2012, I think, was renamed to Elizabeth Tower in honor of Her Majesty the Queen. They stand 38 meters apart. From Susan's position, 65 degrees, and from Jorge, it's 49 degrees. To me, that sounds like Susan is closer than Jorge because she has to look up more steeply. So we're looking at something like this. Susan is 65 degrees and Jorge is 49.5 degrees. The only thing that we know is that between them, they're 38 meters. We get some really fun things going on here. And when I say fun, I mean super fun, because we're trying to find this thing. And the way that we're going to end up doing this, and although you could do this with law of sines without too much difficulty, is using nothing but right triangle trig. Specifically, we're going to call this side, let's call this y so it's vertical, and we'll call this x. So I'm going to say the tangent of 65, this is for Susan, is equal to y over x, because that's what I've written here. Then we get to the fun part. The tangent of 49.5 degrees is equal to y over x plus 38. We have a system of equations here with two variables. How cool is that? Don't even say it's not cool, because I know it's cool. I'm going to do some calculations to get some decimals. So we got tangent of 65. That's 2.145. 2.145 multiplied by x is equal to y. And for the other one, tangent of 49.5, tangent 49.5 is 1.171. 1.171 times x plus 38 is equal to y. Hey, I could set these equal to each other, and we'd get 2.145x is equal to 1.171x plus, and then we've got 38 times 1.171, 44.498. If I subtract the x's to the same side, 2.145 minus 1.171, we get 0.974. X is equal to 44.498. 44.498 divide by 0.974. And we get that x equals 45.686 meters, which is not all that wonderful because, well, you don't actually have that information. Because what we need is y, not x. Oh, man. So 45.686. I might solve this problem again and say tangent of 65 is equal to y over 45.686. We already did tangent of 65. It was 2.145. So 2.145 multiplied by 45.686 should give me a value for y. So we've got 2.145 times 45.686, and we get 97.99647. So basically 98 meters tall. And I'm going to do some quick Googling. How tall is Elizabeth Tower? And Elizabeth Tower is 315 feet. I'm going to convert that to meters because Google's good at that, I hope. It says 96 meters. I got 98 meters. That's so far off. Oh, come on. Stupid math problem. Next up, we got laws of sines and cosines. We got to solve some triangles. So I'm going to draw this guy. This is triangle ABC. And angle A is going to be 95 degrees. Angle B is 50 degrees. Since I know two angles, I know my third is 180 minus the sum of those two. So 180 minus 50 is 130. Minus 90 would be 40. Minus another 5 would be 35. And I also know angle C is equal to 15. I'm going to label opposite B as B and label opposite A as A. In looking at this, I've got a paired side and angle, so I can use law of sines for this. So we'd be starting with sine of 35 over 15 is equal to, I don't know, let's do B first. Sine of 50 over B. I'm going to multiply both sides by B and then divide both sides by this stuff. We end up getting B is equal to 15 sine 50 divided by sine 35. And when I actually calculate that, so 15 times sine 50 divided by sine 35, we get that B is equal to 20.03. So I'll leave that as 20. Then I can figure my third one out. And that's going to be based on doing sine 35 over 15 is equal to sine 95 over A. Similarly to how we solved for B, we're going to end up with A is equal to 15 sine 95 over sine 35. And when I plug that in, 15 times sine 95 divided by sine 35, we get that A is equal to 26.05. I'll leave that as 26. Number 2, we've got triangle STR. And here, we've got R is 27.8. S is 24.8. And T is 24. Okay, and looking at this, I have all three sides. I don't have any angles, so I can't use law of sines. I've got to use law of cosines for this. Kind of arbitrarily, I'm going to choose S to go for first. So we get 24.8 squared is equal to 24 squared plus 27.8 squared minus 2 times 24 times 27.8 cosine of S. It's the cosine of S part I want to get by itself. First thing I'm going to do is take 24.8 squared and subtract from it 24 squared and 27.8 squared. So 24.8 squared minus 24 squared minus 27.8 squared, and I get negative 733.8 is equal to, and then I'm going to multiply these guys together, negative 2 times 24 times 27.8. Negative 1334.4 cosine of S. I'm going to divide by 1334.4, divide by negative 1334.4. We get negative 733.8, divide by negative 1334.4, and I get my calculator die. It's always fun when you press enter and your calculator just shuts off instead. So I'm going to use Desmos. So we got negative 733.8 divided by negative 1334.4, and we get 0.5499 is equal to cosine of S. That means that if I do the inverse cosine, arc cosine of both sides, so 0.5499, we get 56.639 degrees. So 56.6 degrees would be that. At this point, I've got a couple different options. I could do the law of cosines again. At this point, I could do law of sines and do something like sine of 56.6 divided by 24.8 is equal to sine of t divided by 24. Use that to solve for t. That's a little bit shorter than what we just did, so that's probably what I'll do. So if we do sine of 56.6 divided by 24.8, and then times 24, we get sine of t is equal to 0.8079. If I do arc sine of that, or inverse sine of that, we end up getting t is equal to 53.89 degrees. And then using my third angle theorem, so 53.89, I could do 180 minus 53.89 minus 56.6, and we get 69.51 degrees. The word problem down below, we're in charge of collecting rent. We've got to base this on the square footage. So we've got to do some work to figure out what the square footage of this store is. In order to do this, I probably need to figure out some pieces of information in this triangle. I don't have a way to figure out the area of irregular quadrilaterals. So I might need to do some stuff here. I'd like to remind us that we have an area formula that we developed for using trig, which was 1/2 AB sine of angle C. So for example, if I cut this into two triangles, not that I need it for this bottom part, but I could do 1/2 times 100 times 100 times the sine of 90. And that would give me the area for that triangle. I can't do that for the one up top because I don't have enough information yet. But let's see what we can do from this. Okay, if these two guys are 100, and I am going to keep this divided up into two triangles because I think that's a useful thing. This is 45. This is 45, and I know that because this is an isosceles triangle. And if this is 45, to make 100, this top part's got to be 55 degrees. I also know that if these two legs are 100, this hypotenuse to the right triangle has to be 100 times the square root of 2. So I'm going to call this area 1, this guy area 2. Area 1, which is a right triangle, we can use 1/2 base times height, which is 1/2 100 times 100, or 5,000. For the other guy, I'm going to use the area formula that we developed. And just as a reminder, we developed that by drawing altitudes down, but then we didn't really need that anymore. Because I've got 1/2, I'm going to do AB sine of the angle between them, which is 1/2 times 67 times 100 square roots of 2 times sine of the angle between them, 55 degrees. When I do this out, so 1/2 times 67 times 100 times the square root of 2 times sine of 55, we get that's equal to 3880.827. When I add those together, we get 5,000 plus 3,000 is 8,000, 8880.827. So that's the area of that. There are a couple other ways that I could do that, but I think that's about the shortest way that I could do that. I could also break this up into a bunch more triangles, but let's try to avoid that. So at $14 a square foot, we're going to multiply the number that we got there, 8880.8, which is what we were asked to do to the nearest tenth, times 14. And at $14 a square foot, that's going to be $124,331.2. That seems like a lot of rent, but that's okay. That's pretty insane. That might be more of a purchase price than a rent price. I just kind of pulled $14 out of my head as a number that made sense. And I guess it really doesn't, because that seems like a lot of rent for 1 month. But that's okay. Maybe it's a really cool space. And finally, we're looking at some unit circle trigonometry. A couple things we got to be able to do. The first is go from degrees to radians. I'd like to remind you that in a circle there are 2 pi radians and that there are 360 degrees. We're going to be using the scale factor again and again and again in order to simplify these problems. So going from 33, we've got 33 times 2 pi over 360. That's going to be 66 pi over 360. I know I can divide both of these by 6, and that would give me 11 pi over 60, which is my final reduced answer. 450 degrees, that'd be 150 times 2 pi over 360, or 300 pi over 360. My last zeros cancel out. 30 over 36 is 5 over 6, and I still have a pi. That's my final answer. Going from radians to degrees, I'm going to go the opposite direction. So negative 5 pi over 3. I know I've got to get rid of the pi, so my 2 pi is going to go on the bottom, and 360 is going to go on the top. If you'd like to engage in some cross-canceling, this is a great opportunity to do that. For example, 360 and 3 can be reduced to 120 and 1. 120 and 2 can be reduced to 60 and 1. And my pi's cancel out, leaving me with negative 5 times 60 over 1 times 1, which is negative 300 degrees. And then 7 pi over 6. So we've got 7 pi over 6. Again, I want to get rid of that pi, so pi is going to be on the bottom. 360 over 2 pi. My pi's cancel. My 6 and 360 can be reduced to 1, and 360 divided by 6 is going to be 60. I can go a little bit further. 60 and 2 can be divided into 30 and 1. So we get 7 times 30 over 1 times 1, which is 210 degrees. Name two angles, one positive, one negative, with a given coterminal angle. I've got to sketch the angle and find its reference angle. I'm going to actually do that part first because it's a little bit easier. 84 degrees is going to be a little bit less than 90. It's also going to have a reference angle. I've got to go back down to the x-axis, and that's going to be 84 degrees. That's interesting. It's in the first quadrant. Its reference angle is itself. Coterminal angles, I'm going to do 84 plus 360 to get a positive one. And in doing that, I've got 444. And I'm going to do 84 minus 360 to get a negative one. And that's going to be 84 minus 360. Well, minus 60 would be 24. Minus 300 would be something like negative 276 degrees. There's my positive, there's my negative, there's my reference, there's my picture. 2 pi over 3. Again, I'm going to draw this first. Well, that's a 2/3 is going to be not quite to 1, so pi is over there, but it's going to be bigger than a half, so it's going to be somewhere in second quadrant. The reference angle, so how do I get from pi to 2/3 pi? So pi minus 2/3 pi would be 1/3 pi, or pi over 3. That's my reference angle. To get a positive and negative coterminal angle, we're going to start with a positive. 2 pi over 3 plus 2 pi, which is really going to be times 3 over 3, 6 pi over 3, and that would be 8 pi over 3. To get a negative one, we've got 2 pi over 3 minus 2 pi, because that's a full circle, which is really 6 pi over 3. That equals negative 4 pi over 3. The last piece, we've got to determine the exact value of some trig functions. We can do this in a couple different ways. We've been talking a lot about using coordinates to do this. So I might think about this in terms of my unit circle. And we've got 1, 0, at 30, 45, 60, we're looking at 1/2 comma the square root of 3 over 2. And sine of 60 is going to be the y-coordinate there, or the square root of 3 over 2. I could also have set this up as a right triangle. And I know that we're going to have root 3 over 2 opposite the 60, 1/2 for the short side opposite the 30, and that sine of 60 would be opposite divided by hypotenuse, or root 3 over 2 over 1. I get to the same answer using a different way. For the second one, 3 pi over 4, that's going to be 3/4, so we're like there. In fact, that's going to be a 45-degree reference angle. The coordinates here are going to be the negative square root of 2 over 2, comma the square root of 2 over 2. For cotangent, that's going to be x divided by y. It's the reciprocal of tangent. So negative root 2 over 2 over the square root of 2 over 2. Same thing over itself is just going to be 1, but I've got a negative, so we get negative 1 as an answer. Other thing we can do is figure out what quadrant this is in. It's in quadrant 2. Cotangent is going to be negative in quadrant 2 because one of the coordinates is negative. And if you realize this is a 45, 45, 90 right triangle, any 45, 45, 90 that you construct, you're going to put the same thing. So if we get x, x, x root 2, cotangent would be adjacent divided by opposite, which is x over x. Because we're over here, my horizontal value is going to be negative. So we end up with negative 1 as an answer.